Oh, hello everyone. Welcome to this comprehensive guide on system design fundamentals. In this presentation, we will explore the essential concepts, principles, and practices that form the foundation of designing scalable software systems. Whether you are preparing for system design interviews or looking to strengthen your architectural skills, this guide will provide you with a structured approach to mastering the system design. So let's go ahead. So what is system design? So system design is more than just drawing boxes and arrows. It's a comprehensive discipline that requires you to master numerous concepts, terminologies, and architectural patterns. Like think of it like learning a new language. You need to understand the vocabulary before you can have meaningful conversations. So in system design, these terms and concepts are used daily when discussing architectures, making decisions, and solving problems. So the foundation knowledge becomes the basis for all of your future decisions. And what is the learning approach that we will follow? So we will basically follow the bottom-up methodology. So we won't start by designing like Netflix or YouTube right away. Instead, we will begin with fundamental building blocks, understanding what each component does and why it exists. Then we will learn how these individual components work and interact with each other. Gradually, we will integrate these pieces into complete architectures. And finally, we will understand how to build production-ready distributed system. So this structured progression ensures that we have a solid foundation before tackling complex designs. So before going that, let me just tell you the reality of system design. So here's something crucial to understand that system design is not like coding problems where there is one correct answer. So multiple architectural approaches can effectively solve the same problem, each with its own trade-offs. So for example, you could use a monolithic architecture or microservices. Both can work, but they have different applications. This is what makes system design both challenging and interesting. So your intuition and pattern recognition will develop through practice and exposure to different scenarios. So over time, you will gradually start recognizing like which pattern fits the which situations. Then system design interviews. So many people preparing for interviews like find system design intimidating because it's so different from the coding interview. Because system design interviews are very subjective and conversational in nature. Unlike algorithmic problems like with definite solution, these interviews evaluate our thought process, like how we make decisions, how well we communicate our ideas. So the interviewer wants to understand how you think, not just what you know. They are interested in the journey, how you arrive at your solution, not just the final destination. Uh, So, in continuing with that, like during a system design interview, you also have like specific responsibilities. So, first, you have to articulate your rationale, like explain why your proposed architecture solves the problem. Then you have to justify your design decisions, like why did you choose PostgreSQL over MongoDB, and why microservices instead of monolith. Then third is that you have to perform the comparative analysis, like acknowledge what other alternatives are and explain why you choose the one you tell. Then the fourth is proactively address trade-offs, like don't wait for the interview to point out problems. Then finally, and position your solution clearly, like is it the optimal solution or one of the several good options or a pragmatic compromise? So this clarity is what interviewers appreciate. So now let's go to the four pillars of system design. So to make learning systematic and manageable, I organized into four interconnected pillars. So think of these as the four corners of a strong foundation. So each pillar supports the others, and mastering all these four can give you the comprehensive system design expertise. So we'll explore each pillar in detail, understanding not just what they are, but how they work together to create robust systems. Let's go to deep dive in each pillar now. So yeah, pillar one. So it is a foundation knowledge. So these are the core networking and architectural concepts. that underpin every distributed systems you will ever design. The client server model teaches you about request response architectures, like how client requests data and how servers respond. Then network protocols like HTTP, TCP, IP, and WebSockets. It defines how systems communicate, and API design principles that help you to create interfaces between components. And understanding data flow shows you how information traverses through your system. Without these fundamentals, everything else becomes shaky. Like these concepts form the bedrock of system design. Then system characteristics, non-functional requirements. So it is also known as non-functional requirements or quality attributes. So these define how well your system performs, like not just what it does. Like availability measures system uptime, like can users access your system when they need it. Latency focuses on response time, like how quickly does your system respond. Throughout measures the capacity, like how many requests can it handle per minute. Then consistency ensures data integrity. Do all users see the same data? Reliability covers resilience, like can your system recover from the failures? So these characteristics often compete with each other, and understanding these trade-offs is crucial for good design. Then third is system components. So these are the actual building blocks you will use to construct your architecture. So load balancers distribute incoming traffic across multiple servers, enabling horizontal scaling. Caches store frequently accessed data in memory for faster retrieval. Message queues enable asynchronous communication between services, decoupling components. And similarly, database handle data persistence and retrieval. CDNs distribute content geographically closer to users, and API gateways manage request routing, authentication, and rate limiting. So each these components solve specific problems, and knowing when and how to use them is essential. So you will combine these components, like we used to do in kids, like we use Lego blocks to build a complete system. Yeah. Then actual technologies. So yeah, so the specific tools and platforms are used in production environment. Like the previous pillar that we discussed, con use concepts like cache or message queue, but this pillar is get specific. Like Redis is a popular in-memory store for caching. Then Kafka handles distributed event streaming. Then DynamoDB is AWS's NoSQL database for scalable storage. Zookeeper manages distributed coordination. Elasticsearch powers search functionality. Kubernetes orchestrates containers. SNS and SQS are AWS messaging services. So understanding these technologies means knowing their strengths, limitations, and use cases. So when you say I will use Redis for caching, you should know why like Redis and not another solution. Then how all these pillars work together. So yeah, I will show it with a real example. So imagine designing a video streaming services like YouTube. So first you will start with the foundation knowledge. So you will get to understand what is the client server architecture and HTTP protocols for video delivery. Then you will consider the system characteristics that you require low latency for smooth playback and high availability so users can watch anytime. Then the third is you have to select the components, like you have to select CDNs for content delivery and load balancer for traffic distribution, caches for metadata. Then the last one is you have to choose a technology. Like for caching, you will use Redis, and for event processing, you will use Kafka. For video storage, you will use S3, then CloudFront as an SDN. So this is how this all four pillars integrate. So this is how you have to approach on any system design problem. Then key takeaways. So yeah, before we conclude, let's recap the key takeaways. So first, remember that multiple solutions can work. Your job is to choose based on trade-offs, like not finding the perfect answer. And second is that practice consistently because intuition develops over time. And the third one is to master all those four pillars that we have discussed earlier systematically. Don't skip the foundations. And the last one is like always focus on why you made a decision, not just what you decided. And fifth, like communication skills are as important as technical knowledge. So yeah, finally, like learn from the real world examples. Like they provide context and make concepts stick. So yeah, keep these principles in mind, like as we move forward. So yeah, so from the upcoming videos, like what's our learning path forward is like now that you understand the framework. So yeah, we will take a deep dive into each of these four pillars with practical examples and real world scenarios. We will learn how to analyze trade-offs and make informed decisions. We will cover interview preparation strategies with practice problems. And yeah, remember that system design mastery is iterative and each concept's built on previous knowledge. So don't worry if everything doesn't click immediately because like with consistent practice and exposure to like different problems, you will develop the intuition needed to design these robust systems.